Okay, did I call it? Yeah, Px/8. So based on this diagram over here, right, it's tensile. Okay, so when it's tensile, this is our stress, and it is independent on the y distance. Okay, so this is our stress. So I'm going to draw exactly where it stops each. Okay, so at this stage, at this point, is our positive Px/A. Okay. Then the next one we are going to draw due to our bending, and most of you are very familiar how to draw it now, I hope, because I asked you in your quiz to sketch your stress profile, right? So this is your y. So this is still your stress x. So we know that the top is in compression, the bottom is in tension due to the bending. So this is how your stress field will look like. Okay. So this is how your stress field will look like now. Okay. So for this case, you are applying that stress x is equal to mz over izz multiplied by y. Okay. So based on the parent function also, okay, you have your y is changing. That's why your values are changing in your stress x direction. So if you look at this formula over here, okay, this can be plus or minus. Okay, don't worry about it. I taught you how to deal with this is by visualization, right? If it's plus means it's tension, it's minus means it's compression. Okay, and it's based on the moment vector over here, tensile, compression, and you know this tensile. Later on we will do an example, you'll see this clearer. Okay, so as I said, do not worry about the sign. In fact, down here there's a plus minus also. Don't worry about that yet, because you only need to be concerned about it during your analysis. Okay, I don't want you all to just plug in formula. I want you all to visualize. Okay, so based on the formula, you add both of them. Okay, so normal stress add by bending moment. So the outcome is this. Okay, so for right, so now your stress x is equal to px over a plus by mz over izz multiplied by y. Okay, so all I need to do now, I copy this, I come here, I paste. Now this is our result. Okay, this is stress x. Right. Now this is where it's critical to know. Okay. So if you look at centric loading, right? So this is centric loading where mz over izz multiplied by y. So for centric loading, the centroid, which is applied due to geometry, right? The centroid is fine by using geometry, yes or no, right? We come up with this table, right? You come up with this table, right? It's all geometry where we used to find centroid. Okay, it's all geometry. Okay. Now, so that's why I say the centroid is geometry. So in centric loading, the centroid position is the same as the neutral axis. And the neutral axis is based on what? Stress field. Okay. So you see, I'm going to make a very dark line. This pink line. Okay. So where you see, can I increase it? Yeah. Okay. Okay. So where you see this pink line is, okay, this is the position of the centroid and neutral axis. Okay. However, in eccentric, so this case we have a px plus by mz over izzzy. In eccentric loading, right? So we know that at this line over here is where stress x is equal to 0, right? So we know, right? We know that this is our centroid, right? And where stress x is equal to 0, what position is what position is at now? So I'm going to now draw the position. So the position of the neutral axis, right? So you can see the neutral axis and the centroid are not at the same position anymore, right? There's a shift, right? Because the neutral axis is based on the fact that stress x is equal to what? 0. Okay, so at this point, you can see stress x is equal to 0, right? So in eccentric loading, the centroid position right is different, or has the centroid position is different from the neutral axis. Okay, that's where the difference comes in. Okay, so that is the difference between centric, okay, centric loading and what? Eccentric loading. Okay, and the shift is because of our what? Of our axial load. Okay, so now I'm going to, what if now, okay, so what if now, give me 5 more minutes, we go for a break, then we do the example. Okay, I need to elaborate this point. Okay, what if now okay, we change this. Okay, what if now, right, what if now over here, okay, I'm going to cancel this, and cancel this. What if now, okay, if our stresses or our applied force are doing this, right? So our F now will come in this way. Then our moment now will be acting this way, right? So this is our moment in Z. So now the axial load will now induce a what? Compression. And then this will induce a compression over here. And over here will be a tensile. Now it flipped over, yes or no? Right, that's why I told you, do not worry about the formula. The only formula that you have to remember is stress X is equal to Px over A, okay, mz over Izz multiplied by y. Over here, whether plus or minus, you don't need to worry. So for here, you know that this is going to be what? Minus. Over here, it depends whether on your moment vector, whether are you below the centroid. If it's below the centroid, it's compression. Is above the centroid, it's tension. So let me briefly sketch this out. Okay, how does this look like now? Okay, so I'm going to do some copy and paste. Okay, let me see. Do I have enough space? I have more than enough space, and I'm going to do some shifting. Okay, not really shifting. I can't. Yeah, maybe I can. Okay, I'm going to do some magic. Okay, so the formula is still the same. Copy and paste. Okay, so we got it here, and we're going to change some things. Okay. Sometimes this works, sometimes this don't work. Okay, it will work now. Okay, so now you will see now. Let me. So the formula is still the same. Need to get rid of this. So now we have what? We have compression. Okay, so now we're going to shift this. I'm going to shift this. It's in compression now. Okay, it's in compression now. So rather than plus, now it's going to be minus. Okay, now it's going to be minus, right? Because this is under compression. Okay, and then now this will flip over. Yes or no? This will flip over. So I'm going to flip. Where's my flip? I'm going to flip horizontal. There you go. So now this is the stress distribution now. Okay, now this is going to be the stress distribution. So on top you have tensile, below your compression, and then finally over here you're also going to what? You're also going to flip. Okay, now after you flip, it's going to compression. So you have this, you shift over here. Okay, so you shift towards the left, shift towards the left. Again, that is your new position of your neutral axis. Okay, are we clear? Okay, so I just show you what if we do a flip inside, your stress field will be different. Okay, will be different. Okay, what I'm going to do now is we're going to take a break, and after our break, I want you to look at this question over here. Okay, we are going to deal with this question over here. It's not a difficult question. It's quite straightforward. Okay, so what we will do is we will find the stress, and what I'll do is I will sketch the stress field for you also. Okay, we're going to sketch the stress field. Okay, we're going to sketch the stress field based on this profile. Eugene, what am I doing? Yeah, I'm doing silly stuff. Okay, always in a rush. Okay, go for your break. We come back at 10:45. Okay, I'm going to stop recording. We're going to come back at 10:45.